In this video, we're going to be talking about drawing Lewis dot structures that have multiple bonds in them. So we're looking at this example of carbon dioxide, or CO2. In this molecule, we have carbon, which has 4 valence electrons, and oxygen, which has 6. So in order to make it so that each of the molecule, or each of the atoms, fulfills the octet rule, has 8 electrons around it, what we need to do is add multiple bonds. So how did we know that CO2 has double bonds? It's because we needed to fulfill the octet rule. So under here, we're going to talk about how are the steps? What is the math that we use to figure out if we need more bonds or not? So the first step of what we're going to do for this, number 1, is to calculate the number of valence electrons in CO2, or in the molecule that you're talking about. Let's actually make this all matching in color. How many valence electrons? Okay, so to find this, we're going to take the number of valence electrons for each of the atoms, unbound, bonded to anything else, and add that together. So carbon, we know, has 4 valence electrons, and then oxygen has 6 valence electrons. So our total number of valence electrons is going to be 4 plus 6 plus 6, because we have 2 oxygens, which equals 16 valence electrons. Okay, step 2 in determining how many bonds we're going to need in our molecule is going to be, what is the number of theoretical electrons in the molecule? So we're going to ask how many theoretical electrons. So in order to find this out, we're saying how many total electrons, if everything is bound and follows the octet rule, are we going to have? So in this case, we have 3 atoms, and all of those atoms want 8 electrons to fulfill its octet rule. So if we have 3 atoms times 8 electrons each, that means our theoretical number of electrons is 24 electrons. And then our last step in determining how many bonds is we're going to ask how many shared electrons. Ooh. How many shared electrons do we have? What do we mean by this? This means what is the difference between the theoretical and the valence, because those are the number of electrons that need to be shared between 2 atoms in order to make it so that we're having enough electrons in each orbital. So to do this, we're going to take our number of theoretical electrons, and then we will subtract our number of actual valence electrons. So theoretical minus valence. And that's going to equal our shared. So in this case, we're going to have 24 minus 16, meaning we will have a total of 8 shared electrons. what that corresponds to, if we have 8 shared electrons, each shared electron must be in a bond. That means we have to have 4 bonds total in our whole molecule. When now looking back at CO2, we do see indeed that we have 4 bonds in this molecule. So now, once you've calculated how many bonds you need, then you just need to kind of put the puzzle together in terms of how am I going to fit everything together in order to get 4 bonds and everything to have a full octet. So let's do another example. We have nitrogen here. In order to have N2 molecule of nitrogen, we must have 3 shared pairs of electrons or a triple bond. So we're going to do our calculations up in this corner real quick. So our first calculation is going to be our number of valence electrons. So we've already drawn it out here. We have 5 for each nitrogen. So we're going to have 5 plus 5. That means we have 10 valence electrons. Okay, number 2 is our number of theoretical electrons. So if everything had a full octet, how many would we have? So we have 2 atoms and we have 8 electrons each, meaning we have 16 theoretical. And then lastly, we have our number of shared electrons. So we'll have our theoretical, 16, minus our number of valence electrons, 10. And that equals our shared, which is 6 electrons are shared, which corresponds to 3 bonds. So we know that that is true when we're looking at our actual molecule. Once we've completed it, we have 3 bonds between each nitrogen. Okay, we're going to do one practice example real quick with having multiple bonds. So our first job is to calculate how many bonds we're going to need in this molecule. So step 1 again, how many valence electrons? Silicon has 4 valence electrons. If you look at the periodic table for silicon, let's write that a little different. Si equals 4. And then oxygen is 6 valence electrons. So total we have 4 plus 6 plus 6, which is 16 electrons. For our valence electrons, let's write that out fully. Then we're going to calculate our number of theoretical valence electrons or theoretical electrons. We have 3 atoms. Each of them wants 8 electrons, which is 24 theoretical electrons. And then we're going to calculate our number of shared electrons, which is going to be our number of theoretical minus our number of valence, which is 16. And 24 minus 16 is 8 electrons, which means 4 bonds. So now we know we're going to need, between these 3 atoms, we need to have 4 bonds. So what I like to do is to pick one element and put it in the middle. In this case, I'm going to pick silicon. We're going to draw it a little higher. So I'm going to have silicon in the middle, and I'm going to draw all its valence electrons. So we have 4 valence electrons around silicon. Okay, and then we're going to have oxygen. We'll draw 1 on either side. And I'm going to draw its 6 valence electrons. I'm going to change these just a little bit. So we're going to have our 1 on top, 1 on the side. There we go. Okay, so now in order to make sure we have enough electrons or enough bonds so that we fill the octet rule, I'm going to circle the atoms where they're going to be bonded together. So the easiest bond I'm going to make is the oxygen and silicons that are pointing towards each other. Circle those together. So we have 2 bonds now. We already calculated that we know we need 4, so we need to add 2 more bonds. And we need to figure out where they're going to go. So I see that down on the bottom, I have open electrons that can form a double bond between the silicon and oxygen. And then again, I have another place where I can form a double bond. So my final molecule is going to have silicon in the middle with a double bond to oxygen on either side, and then 2 lone pairs on each oxygen. So let's double check that we followed the octet rule. Oxygen has 4 electrons in its lone pairs, and then 4 electrons in the double bonds. Therefore, it follows the octet rule. And then silicon has 8 electrons in its 4 covalent bonds, and it follows the octet rule as well. And then the oxygen on the right side is the same as the oxygen on the left. It is a symmetric molecule. So it also follows the octet rule. And that is where this video is going to end. And we'll pick it back up with our next topic whenever you decide to watch the video. See you guys there.